I don't think you'd ever get through a trigonometry class or any class that goes through trigonometry without dealing with a problem that deals with a ladder leaning against a wall. So, example 18 here, we have a 24-foot ladder positioned against the wall that forms a 75-degree angle with the ground. How high up the wall does the ladder reach, and how far is the base of the ladder from the wall? When you get situations that are describing a picture to you, it's a good idea to draw a picture. Now you're going to see here. I'm an artiste, and I really draw this very accurately. I mean, here's my ground. It's a horizontal line, wall, vertical line. I'm safe doing that. We tend to build most of our walls vertical to the ground unless we're on a hill or something like that. But we're not told that we have, any kind of hillside thing going on here. So I'm just going to do a basic rendition of it. And I have my ladder leaning against the wall, which is like that kind of silverish gray line there. It's kind of wavy here because that's the way that, for some reason, when I draw things, that sometimes it's the way it comes out. But it's a 24-foot ladder, and it makes a 75-degree angle with the ground. Always make sure that you're paying attention to the description and putting the things in the right area. You're asked two questions: how high up the wall does the ladder reach, and how far is the base of the ladder from the wall? So when I answer part A, I'm labeling these A and B because of the fact that, A is going to answer part A. How high up the wall does the ladder reach? And B is going to answer part B, how far is the base of the ladder from the wall? Because that's a distance there as well. Now, the reason why I chose sine, I'm going to use the angle 75 degrees. I obviously want to use the side A in my calculation because I'm looking for what that is. And I'm going to use the side 24 feet. And when I look at the relationship between that 75-degree angle, side A, the thing I'm looking for, and the hypotenuse being 24 feet, I have a situation where I have opposite leg and a hypotenuse. That's a sine function I'm going to use. So the sine of 75 degrees is going to be A over 24. And to solve that very simple equation at this point, I'm going to do 24, multiply those sides by 24, and get A equals 24 times the sine of 75 degrees, which is about 23.18 feet. So there you go. That's how you calculate that. Now, as far as B goes, yeah, I could use the Pythagorean theorem, with the 24-foot side, this side I just calculated. But again, if I'm looking for a second thing in a triangle situation like this, I could figure it out independently of the others. I should go and try to do that. Only because of the fact that I don't want any potential mistake or any over rounding I may have done in the previous calculation carry over and throw off my answer for part B. And then at the very least, if I want to use, so I said I could use Pythagorean theorem here, but I might want to use the Pythagorean theorem to check my final answer when I'm done to see if it makes sense with the other answer that I got before, as well as that 24-foot side. And that would be a verification that what I have is correct. So I'm going to decide instead that since I'm going to still use the 75-degree angle, I'm still going to use the 24-foot hypotenuse length. I'm now going to use B as being the adjacent leg, so I'm going to say that the cosine of 75 degrees is going to be B over 24, and B would therefore be 24 times the cosine of 75 degrees, which means B is about 6.21 feet. Now, if I take 6.21 squared plus 23.18 squared, I do get a value that's pretty close to what 24 squared would be. It's not going to be exact. I mean, the more decimal points places I keep, obviously, the closer the answer would be. However, that would be an indication that I'm right, so, and it's also not carrying over any potential rounding issues, so, that's the way you want to go with it.